This video will show you how to replace the circuit board on your air turbine. Here's the circuit replacement kit. The silver bag contains a circuit board, so be careful with that. The other bag contains everything else listed in the circuit replacement instructions, which come with the kit, and make sure you have a copy of those with you when you do this. First, you're going to have to disconnect the wires and remove the turbine from the mount, as per the air owner's manual. Next, remove the nose cone. Get your fingers underneath and pull straight out to unclip it from the hub. Next, you'll use a 5/16 inch hex key to remove the blade hub assembly. You may need another tool like a screwdriver in order to gain leverage because the rotor is attached very securely to the hub. Now it's important to realize that you have to turn the hex key this way to the right because you're loosening the rotor rather than the rotor nut. So you can insert a tool like this to gain leverage, and you may even need a rubber mallet to get the hex key to loosen the rotor. Next, you're going to use a 5/32 inch hex key to remove the 3 screws from the face of the turbine. Now use a flathead screwdriver to carefully pry open the face, and be careful not to damage the O-ring, or if you have a marine unit, to not damage the paint. Go ahead and attach the anti-static wrist strap as per the instructions in the package so that you can ground yourself to the body of the turbine. Now you can lift up and pull the face casting from the body of the turbine. Note the routing of the wires connecting the stator windings to the circuit board. Look at the way the circuit is positioned in the body and how the brushes make contact with the slip rings. Study the exploded view in the manual for part identification. Using a 7/64 inch Allen key, remove the 3 small screws connecting the stator wires to the circuit. Note that it is very easy to strip the threads on these screws or even crack the circuit board when you reattach these screws. So it's important that these screws be later reattached in the same manner and torqued to 10 inch-pounds as specified in the circuit replacement instructions. Here I'm going to demonstrate how to remove the rotor for cleaning. This requires a moderate amount of force, so grasp the face casting with both hands, use the palm of one hand to push the rotor shaft straight in, and then use your thumb to push it all the way through and pull the rotor out. Now try spinning the face bearings with your finger and make sure that you don't feel any significant play and that they feel smooth. Use a pair of external snap ring pliers to remove the snap ring from the groove that's right below the slip rings on the yaw shaft assembly. You may need another tool like a screwdriver to assist in removing the snap ring. Once the snap ring is removed, use a hammer and a blunt object or a plastic mallet to drive the yaw shaft assembly out by hitting on the top of the slip ring assembly. You may need to use a moderate amount of force, but be careful if it requires more than a moderate amount of force, or if you have concern about the well-being of the balance of components due to the force necessary to remove the yaw shaft, do not attempt to force the yaw shaft out of the body. Contact Primus Wind Power for advice on how to proceed. Now let's start cleaning. Use a paper towel to wipe the metal debris off the magnets on the rotor. Now grab a fresh paper towel and clean the extra carbon debris off the snap ring and slip rings, as you can see here. Go one step further by grabbing a Brillo pad or emery cloth and wiping the more ingrained carbon debris from the slip rings. Keep in mind that the slip rings don't have to look brand new. Just go until you're not getting any more carbon debris off. It's normal to have tracks from the brushes left on the slip rings after you're done cleaning. Grab a fresh paper towel and clean the rest of the interior of your air turbine. Next, use a 1/4 inch socket or nut driver to remove the 2 screws that hold the circuit to the body casting. These are the screws on the left and right side of the solid metal rectifier, which is item 13 on the exploded view in the instructions. A flathead screwdriver will work to finish removing these screws. Be careful as you remove the circuit from the body because it is still connected by a ribbon cable that goes to the potentiometer and LED light. Go ahead and unclip this ribbon cable from the circuit, as shown here. Use a 5/16 inch socket or nut driver to remove the potentiometer nut on the side of the unit. Note that you might have to modify your tool to fit into the body contour on the air. You may need to grind or file to make a thinner wall of material on your tool. The potentiometer should give way very easily. Clean the excess silicone off the turbine. Next, you're going to use a tool like a screwdriver handle or Allen key to push the LED into the body. Make sure you push on the LED and not on the clip holding it. Pull the old wiring harness out of the turbine. Turn the body upside down and shake it to remove any debris. Use compressed air to get any remaining debris out. Thoroughly clean the flat surface on the body where the circuit is mounted. It is very important that the contact area between the circuit and body be free from debris. Any miscellaneous particles in this area could short circuit the turbine and cause a malfunction. Also, clean the top of the yaw bearing if grease is present. Carefully unpack and examine the new circuit. Carefully look at the pink rectifier insulator pad. Make sure there's no metal burrs and that it's fully intact. It's very important that this pad electrically insulates the rectifier from the body in order for the turbine to work properly. Make sure the small insulating plastic tubes are in place where the screw holes go that attach the board to the body casting. Place the new circuit next to the front of the body and carefully separate the two LED wires as a pair from the potentiometer wires. Leave about 7 inches of ribbon cable intact. Straighten out the wires that lead to the LED by running your thumb and index fingers up the cable. Gently squeeze the wires near the LED together to allow it to properly fit into the LED clip. Do not attach the LED clip yet. Holding the empty body with the yaw shaft on top, gently run the LED wire down the body. Push the LED through the LED hole. Push the new LED clip onto the LED until you feel it snap lightly into place. Apply superglue on the LED and clip. Then guide the LED with clip towards the hole. The LED clip should be flush with the unit. Apply more superglue around the edges of the LED clip so that the glue can run down into the gap around the clip. Remove any excess superglue from the body, being careful not to push the LED into the body. Next, install the potentiometer. Place a bead of silicone on the surface that will mate to the body casting. Insert the potentiometer into the hole on the side of the unit and place the star washer and the nut loosely over the threads. Orient the entire potentiometer so that the slot on the top of the shaft aligns with the dimple on the body. This marks the default setting for the regulation set point for the internal regulator. See Figure 8 in the circuit replacement instructions for clarification. Be careful that the potentiometer wires do not interfere with the LED wires, and make sure that the LED does not pull out of the clip when you tighten the potentiometer. Be careful not to crush the LED wires or potentiometer wires between the body casting and the potentiometer. Before installing your new circuit board, clear out any remaining debris inside the body. Place the circuit in position in the body, aligning the two mounting screw holes. Ensure that the insulator pad adheres to the rectifier and is not peeled or bent away from the rectifier. While orienting the circuit in the turbine, try to tuck the ribbon cable down towards the tail of the body to prevent it from being pinched as the circuit is bolted down. Tighten the two screws so they snugly secure the circuit to the body, approximately a quarter turn once seated. Do not over-tighten the screws as the white plastic insulators may distort and cause a future malfunction. At this point, it's best to stand the body on end with the body opening pointing straight up. Lift the two brushes from the sides on the rectifier using a dental pick tool or equivalent tool. Insert a plastic spring standoff and then a spring in each of the two slots. Place the brushes on top of the springs and then push up and down to make sure the springs and brushes are working together. Check that the springs remain vertical and are not sliding out of the rectifier slot. Make sure the bottom brush wire is between the rectifier and the circular ground sleeve on the body casting. You may need a small screwdriver to push this wire into the proper position. Be sure that the brush moves freely inside the slot. Insert the ground brush and spring into the circular ground sleeve on the body casting. Be sure that the spring side is inside the hole and the solid brush is extending from the hole. At this point, you can perform a continuity test to make sure that the rectifier pad was not damaged when the new circuit was installed. There should be no continuity between the positive brush and the body casting or the negative brush and the body casting. Now it's time to reinstall the yaw assembly. First, make sure that your brushes are in place. Then guide the yaw shaft assembly through the bearing hole and the snap ring. And carefully guide the slip rings over each brush, one at a time. You may find that the brush pops out of place. Carefully push it back in and guide the slip rings over it, one brush at a time. Use caution with the brushes because they're brittle and you could break the wires if you bend them back and forth too much. At the end, you may need a rubber mallet to get the yaw assembly all the way through and the groove exposed for the snap ring. In the end, take a close look at each brush and make sure it's properly contacting the appropriate slip ring. Make sure the spring is properly seated and that the brush wires are not being pinched. Go ahead and grab your external snap ring pliers to reinstall the snap ring. Use compressed air to blow out any remaining debris. Orient your turbine so the yaw assembly is facing towards you. Using the 3 small socket head screws, connect the wires from the alternator assembly in the following order from right to left. Number 1 will go on the right terminal, number 3 will go in the middle terminal, and number 2 will go on the left terminal, which is farther apart from the other 2 terminals. Make sure that you divert wires number 1 and 3 around the pick chip, as shown in the figure here. Make sure not to run the wires over the pick chip because that can cause malfunction. See this figure taken from the circuit replacement instructions for clarity. Carefully snug each of the 3 stator wire mounting screws, ensuring that the connectors maintain the correct alignment. Do not over-tighten these screws, as the threads are easy to strip and you could even crack the circuit board. Tighten the screws to the point where a light push in either direction on the ring terminal does not rotate the screw or ring terminal. This should be 10 inch-pounds of torque. Push the 3 stator wires into the body so they will not interfere with the circuit, yaw shaft, or rotor. As you assemble the alternator assembly to the body, be sensitive to grabbing. Grabbing can indicate the stator wires are interfering with the circuit. Make sure that the wound stator wires do not contact the body casting. Loosely thread in the face bolts. Place the black O-ring around the perimeter of your air alternator assembly and loosely fit it into the gap between the face and body castings. Do your best not to twist the O-ring as you install it. Use a rubber mallet to ensure that the alternator assembly is fully seated to the body casting before you tighten the screws. Now that you have the alternator assembly in place, tighten the 3 face bolts to 35 inch-pounds of torque. Once you have the 3 face bolts torqued properly, perform the 3 bench tests described in the Air Owner's Manual. First test is to take the 3 leads, make sure they're not touching each other or anything else, and give the rotor a flick of the wrist. See how it spins free, it doesn't stop right away? This is how it should be. Now twist the 3 leads together so that they're all making good contact with each other. I'm going to give it a little bit better twist. And do the same with the rotor. Give it a flick of the wrist. And see how it's much harder to turn? You should notice a definite difference. The second test involves connecting your air turbine to the battery. Whenever you connect it to the battery, just double check with a voltmeter, make sure you have the correct polarity on your cables. Here the red is supposed to be positive, so I should get positive voltage when I do this. And I do, so that polarity is correct. Now I've got the turbine connected except for the black. Here's the second test. See the LED come on? It's going to give you 2 blinks, and that's how it should look. For this third and final bench test, we're going to leave the turbine connected to the battery and use a 5/16 inch hex key bit to spin the rotor with a drill. Once we get the RPMs up high enough, the LED should come on, as shown here. This is how it should look. You might notice that the rotor shakes a little when you spin it. That's probably because your drill's not perfectly perpendicular, so don't worry about that. Please see below, or contact Primus Wind Power for how to interpret the results of these tests.